Hey guys, and welcome back to another Android development video. In this video, I will go over my personal top 3 mistakes that I have made in the past 3-4 years as an Android developer that I don't want to make again. I've made them for you. You don't need to make them. Here they are. Mistake number 1. Take a look at this little setup, for example. We have some data classes here for an imaginary chat application with group chats. We have a chat data class, each chat has an ID, each chat has a list of messages, and each chat has a list of some members who are part of that chat. Then for every single message, we have the from person, so who actually sent that message. We have the chat ID this message belongs to, we have some content, we have a timestamp, and every single chat member here in this simplified example has an ID and a username. And now my mistake that I made in the past was this, and it's really a bad one. I went ahead and I created such a chat manager class because I thought, okay, the logic in order to update those chat related states that was in my previous case actually needed across different screens. So you have to imagine that you maybe have some kind of main chat screen where you just see all the chat messages, but then maybe you have a separate screen where you can see all the chat members, where you can click on them to get some details. And all this information is just fetched when you open the chat. And since these states about who is part of the chat, which messages have already been loaded, what the chat is in the first place, whether someone is typing or not, since these things are often shared between multiple screens, I went ahead, I created such a chat manager class. It receives some kind of event pipeline here, so in this case a shared flow, which it would get, for example, from a third-party SDK that is made for chatting, which simply receives notifications about, hey, new member joined this chat, a member left this chat. I don't know, a member is now typing and member now stopped typing. These kinds of events are very common from third-party SDKs. So I thought, okay, why not actually receive those events in a dedicated chat manager class? Here in the init function, you can see I'm launching this flow in an application scope coroutine, and for each type of event, I'm actually just calling a function that updates the state that this chat manager class contained. And in a real-world app, of course, these functions are typically way more complex than simply adding a member to a list or removing it from a list. But what's wrong with this? There are actually multiple things wrong. Problem number 1 is that on Android, there is a thing called process death. Process death, just as the name says, means that the process that your app is executed in dies. And this can happen at any point of time when your app is in the background. Because the Android OS might just think, okay, I'm actually hungry for RAM, the user is currently doing something that requires a lot of RAM, so why not kill some apps that are currently using RAM, which the user is not actively using. Same for CPU usage, same for maybe network usage. So there are just certain constraints under which the Android OS might kill your app when it's in the background. So far, so good. But here's the catch. Normally, when a process dies on a normal macOS or Linux environment, you would simply relaunch it and everything would just start from the very beginning on. However, on Android, Google thought, okay, if an application actually dies due to process death, then there is still this little application window in the recently used apps tab where the user can simply go back to the app. And when the user does that, what Android will do is it will simply restore the previous navigation backstack. So the previous screen history that the user has visited, and they will end up on the previously visited screen even if the process of the app has died before. So there are certain things that are restored after process death, like this navigation history, but what's not restored is the in-memory state that you've kept in the app. An in-memory state is any value of any variable in your app. View model state dies, your singleton state dies, if this chat manager is a singleton here in this example, everything just dies and gets reset to those initial values. Now, process death is something we can't avoid, but what we can do is we can restore those states after process death has happened. However, here comes the catch. Restoring after process death typically only works easily inside of a view model because you need something called a saved state handle for that, which can be used in order to save certain state, like your messages list, your chat members state, and then restore that after process death. And save state handle can only be easily passed to a view model and not to a random class like here, because this task has zero context on the actual current backstack entry, so the current screen the user has visited, while a view model is always bound to that. So passing a safe state handle instance to the view model's constructor is always easy. Doing that to a singleton is pretty much impossible, or you would need a lot of workarounds to make this work. And properly restore those states here after process death has happened. Alternatively, option 2, how you can survive process death, is just persistent storage. Obviously, if you save something in a file, in local preferences, in a database, then that will also survive if an application dies because you can simply reload it. But if you have classes like this, which seems very useful because you can encapsulate certain logic to manage your states, and then you can simply take this class instance and just inject it to all those view models that might need this information about those messages, chat members, whether someone is typing. This will mess up things when process death happens, since everything will be reset. That's issue number 1 with this approach. There is still another issue. The other issue is that if you have such a class, it will very likely become a singleton in your code. So you have some kind of a dependency injection setup. You maybe use Dagger Hill, you maybe use Coin, and then you just initialize this class as a singleton. That means the class will live as long as the process does. And yes, this will allow you to actually share those states between multiple screens, but that is also the same downside. As long as these states are not really needed for every single screen in the app, for every single feature, there is no inbuilt logic that makes sure that those states are actually properly being reset when you don't need them anymore. So assume you have an authentication feature where you just log into this chat application, and you have this actual chat feature where you can then select a chat, you can chat in there, you can open the participants list. Then this chat manager and those states may be needed for multiple screens within this chat feature, but they are certainly not needed in the login screen after a user has logged out, for example. The thing is, if you now have this as a singleton here in your code, and you load certain messages, you load certain members, you just put valid values here in those states, and the user then logs out and re-logs in, then the messages, chat members, and whether someone is typing will still be equal to what they were previously, before the other user has logged out. Of course, you can now say, yes, but I can actually reset them when you log out. But will you always think of that? In my experience, it has happened very often that I forgot this. And then you end up having a list of messages from user A, but you show them for user B. So this approach is very, very error prone. What is now the better approach? Well, the better approach is simply to consequently store all kinds of UI state that you have in your app in view models only in view models. And if you really need such state in other classes, specifically in singletons, then make sure that if process death happens, this is not an issue in this case, because you maybe just reload the state initially from local preferences, or for example, you have some kind of state whether you are connected to some kind of Bluetooth device or so. Then when process death happens, the state will obviously reset to false, so that you're not connected to the remote Bluetooth device, but that is an implication so that automatically happens when the process dies. So for example, if you have a Bluetooth app, you have some kind of a singleton class, you have a state in there, whether you are currently connected to a remote Bluetooth device. If process death then happens, then the isConnected state will be reset to false, but that is clear. If the process dies, then you won't be connected to the Bluetooth device by design. That's just how processes work. Then the connection will die. So in that case, resetting that value to false will not lead to any issues. However, if maybe the user has filled out a very long form, has entered a lot of details, a lot of strings, then it would be very frustrating if they go back and all the data would be lost. But in most cases, if you have state that you really want to show directly in the UI, like this here, place this in a view model. If you need to share the state between multiple screens, then use a shared view model, but only share it for a specific nested navigation graph. So you can create nested navigation graphs where you say, okay, I have those 3 screens. Those 3 screens belong to the chat navigation graph. And then you can say, I have a shared view model, which you bind to this navigation graph. And the moment the user leaves the context of those 3 screens, for example, when they log out, then you would simply pop this navigation graph on backstack. The moment this happens, the shared view model bound to it, bound to all these screens together, bound to the navigation graph, will also die. And that means the state that is kept in the shared view model will also automatically be cleared, because the next time the user gets there, the view model will be reinitialized, and therefore you will start with a fresh new state. So you don't need to keep in mind to actually reset all those states to the default state when the user logs out, for example. So very critical issue. Don't do this. Whenever you have some kind of properties, state flows, var fields inside of a singleton, really ask yourself if this can lead to any issues, and most likely it can. Coming to mistake number 2. Let's take a look at the chat repository that I've prepared. Again, same context. We have a chat application. We have some kind of chat DTO, so a data class that we can load from a remote API, for example. Here really just simplified without real behavior. We have an interface that represents this chat API that provides suspending functions, so functions that take a little while to complete. And on the one hand, we can load some chat data, which is this chat DTO with member IDs, so without the members yet being loaded. But in order to load these, we do have a separate function to load a single member by its ID, and we have a function to get all chat messages, or at least in a paginated way here, so we get a list of chat messages back for a specific chat and a specific page. So far, so good. So if you have something like this, then you likely also have something like this, that you have a repository which relies on this chat API. This could be a retrofit API, could be a K2 HTTP client, doesn't matter. And then in here, you simply call all those functions that in the end are then combined to form such a chat data class that I've shown you previously here. So simply a data class that has all messages parsed and all members also being passed. So we first load the chat data, so we get the member IDs, then we load the chat messages here, and then we go over all member IDs and we map them to the corresponding chat member for that specific member ID, just to then return everything. What's the issue here? Can you spot it? Well, the issue is not properly understanding asynchronous programming. And if you're already very deep into asynchronous programming and coroutines, this will be obvious to you. And trust me, there is an incredible number of people who make this mistake. And making this mistake is not an issue, but learning about that this mistake exists and not doing anything about it, that is a problem. So let's find out what it is. With Kotlin coroutines, we have those suspending functions. Suspending functions are a replacement for callbacks, so we can just kind of execute code that takes a little while to complete in a synchronous manner. So whenever you see this little suspending arrow, that means this code here will actually make some kind of asynchronous call. It will take a while to complete, and it will block this code here until it has the response from this API endpoint here. After it has the response, it will go on with this line, which is also a suspending function. So it gets all chat messages. When it then has loaded all chat messages, it will then go on with this one. It will actually map all those member IDs, so it will internally use a loop here. And for every single member ID, it will again call a suspending function. So it will first fetch member 1. Once that has been fetched, it will fetch member 2, then member 3, and so on. And that means if we have, let's say, 10 members in our chat, and loading a single member takes a second, then this code here will take 10 seconds. However, if you think about it for a moment, then loading member 1 is pretty independent of loading member 2, right? Because the delay of this function mainly comes from the time it takes the network traffic to travel over the network. But if we would initiate all those member requests in order to load a specific member, at the same time, they would also arrive at the remote server at roughly the same time. The server could then also process all these requests and also make respond with a response in approximately the same time. If we would be able to execute all these calls in parallel, so at the same time, then we would strongly speed this up. And again, with the example of having 10 members that we fetch here, we would speed this up by the factor of 10. If we have 100 members, we would speed this up by the factor of 100. So this is a huge thing that you have to be aware of. Whenever you call multiple suspending functions here together, one suspend function does not rely on the other. So one function does not need the result from the previous suspend function. Then you have to execute them in parallel. And the way this works with coroutines is actually not too difficult. We would just want to make use of something like coroutine scope here. Not coroutine context, coroutine scope. Because this allows us to launch individual child coroutines that run in parallel. Because then we can say we don't want to call these suspending functions here directly, but say we launch an async block, so that is an independent child coroutine that holds a certain result we can then retrieve at a later time. Same thing here. We say messages, async, paste that. And for the member IDs, well, that now relies on the data that we've previously loaded. So this call must finish before we can load those member IDs, because before that we don't know those member IDs. So here we can say data.await. Await is now another suspending function that will simply await for this code to finish. However, in the meantime, we're already fetching those messages here because they are also placed in an independent async block. So with the data await, we really get the result from this function. We then take the member IDs, and now here in this map function, for every single chat member, we can again launch an independent child coroutine. So these members can also be fetched in parallel. And then here, for constructing this chat, we can simply say messages.await and members.await all, which is an extension function that works for lists and simply waits for all those async blocks to finish. But now all of those are really executed in parallel, and you will see a huge performance boost here if you really would have such production code. And we do get a little issue here because I've set this equal to a coroutine scope, so we don't need this return statement anymore because the last line here of this code will then be returned. So just ask yourself that if you see multiple of these suspending arrows here in a single function, do these calls rely on each other? Because if no, then make use of async or launch blocks. So launch, on the other hand, would be needed or would be used if you don't care about a specific result from this function, but it's really just a function that does something without returning something. Coming to the last mistake number 3, and for that I actually jumped into a different project, which is called Echo Journal. That is an app that I'm currently preparing and recording a course for. It comes from one of the past app development challenges from my mobile dev campus community. So that's just a community of very committed, close Android developers, where we from Peter Coding regularly provide such app development challenges. So in the form of professionally designed mockups from a real designer, together with requirements to build. In this case, for an audio journaling app called Echo Journal, where you can just record how you feel on a given day. We'll link this with a specific mood, add some tags, and so on. So these challenges are just something people regularly build in order to really practice their coding skills and not just rely on tutorials and courses, because obviously you need to internalize what you've learned by really using that in practice. And for that, we really give everything for that. But that shouldn't actually be the topic of this video. I really want to use this app because it's a very good example of my third mistake, because it affects compose recompositions. So you can see here in our app, we can simply hit play and then our voice memo will start playing. You won't hear this because it's running on my physical device. But let's relaunch this once more and actually take a look in our layout inspector. The layout inspector in Compose is used to track down which composable recomposed how often, so was called again how often. You can see here's our entire Compose hierarchy for the screen. In this column here, we can see which composable actually recomposed and how often. Here the screen root and screen was, for example, recomposed once. And these gray numbers means how often a composable was skipped. So could have been called again, but the Compose framework decided against that because the composable did not reference any value that changed. And it's just really good to track down such recompositions and how efficient your Compose UI is. Now let's see what happens if we actually hit play here. So I hit play. You can notice something interesting. Our entire screen is flashing. This is what the layout inspector does. When a composable is recomposing, then that composable will simply flash here so we can see which parts of the UI are recomposing. If we now take a look here in our layout inspector, we can see, okay, our echo screen root and the echo screen recomposed 255 times. If we scroll down a little bit, well, here our list, so the list of those items here, also recompose because they contain this one element, this echo timeline item that contains an echo card with an echo mood player with an echo play bar. And that contains a box, which this simple component here is, which we need to update while we play this audio memo. And maybe you now think that my mistake refers to some kind of issue that causes those recompositions, especially over the entire screen, right? Maybe you've heard that saying before that premature optimization is the root of all evil. And in software terms, this means don't focus on performance optimization if performance is not a noticeable problem in your app. But you might still be like, dude, this entire screen here is recomposing. This can't be good. But let me ask you a question. What really is a recomposition? A recomposition in Compose in the end is really just a function call. So here in our Compose UI, we have this echo screen. We have this echo screen root in which we just listen to the state. We have some effect handlers here. But then most importantly, pass down the state, which is really just a data class bundling all the screen state, pass this down to the echo screen, which contains the raw UI. And now if this echo screen root, as well as this echo screen here recomposes, that simply means this function is being called again with possibly new inputs. And what Compose will do is, if a function is recomposing, so it's called again with a new state that has changed, it will enter this function and take a look at all those other composable functions within this function that could possibly reference this state that has changed. So it will take a look at this scaffold. Does the scaffold use any specific parameter that did change? Well, not directly. The echo floating action button also doesn't directly reference the part of the state that changed, which is actually the progress of this current playback. So this will be skipped. Then the echo screen top bar, so our top bar with the mood chips here, the filter chips, will also be skipped because that doesn't reference any state. It doesn't reference this progress state. Then this box will be skipped because it also doesn't reference that. It just contains a composable lambda that will again be checked. So circular progress indicator, no. Empty echoes list background, no. Column, no. Echo filter row, no. Echo list, okay, yes, that now uses the state because it displays the entire list of those audio memos. Here, the state.echoes, which then contains the progress fraction for this specific voice memo that we're playing. So this does recompose, which we can also see here for the echo list, was also recomposed 255 times. But this is really what I want to tell you. If an entire screen recomposes, which looks very frightening here in the layout inspector because everything flashes in blue, that is not necessarily worse than a tiny component recomposing. It can be worse, yes, if actually the vast majority of the screen, the vast majority of composable functions in the screen are simply skipped because they don't reference the changed state. Then it's a super simple, super quick function call to recompose that screen. And I feel like recompositions is something that people take a look at way too quickly while ignoring very important other things that would lead to a way bigger performance gain in the UI directly. For example, if you have certain expensive state updates in your view model, do you execute these maybe on a background thread on the default dispatcher? Most people just execute everything in the view model functions directly, which means it is actually executed on the main thread. And if the main thread's load actually rises, then this will also increase the risk of running into lags in the UI. If you have lag in the UI, the issue does not need to be in recompositions. It can be, yes. But then ask yourself, first of all, do you have that lag on certain devices? And if so, yes, then it makes sense to take a closer look at that. But just because a single composable function or these two screen composables here are being called again, that does not mean in any way that the UI is redrawn, that certain things are relaid out, because compose consists of three phases of composition, so that is where those composable functions are called, consists of the layout phase, where it's decided how large certain components are, where they are placed on the screen, and then it follows up with a draw phase, so how these components look like, which color, which shapes, and so on. And the recomposition itself will really, first of all, just re-invoke the composition phase, so that the structure of your compose UI will be re-evaluated. But it does not imply that the layout and the draw phase will automatically also be called again. So it's really just a simple function call, and especially if a lot of those composable functions get skipped, like here, like all those components, you can see those skip counts, then that's nothing to worry about. Again, unless you really run into issues on a specific device. Because technically, with this specific setup, yes, we could achieve a scenario where we could update this specific audio bar here without causing any recompositions at all. This would be possible. You do need to understand the compose internals a little bit for that in order to hack your parameters a little bit. But you would be able to update this UI here without any recomposition. However, this would come with a cost, and the cost would be that we would have to split up the state because we couldn't rely on such a state data class here anymore. We would have to work with a lot of independent states. It would be a lot of pain to update that, and that is a very big cost to pay. So why not rather keep your code organized, keep it easy to change, which will also automatically imply that you are less likely going to run into bugs if that maybe increases recompositions just a tiny bit, but does not lead to any noticeable issues in your code. Because optimizing recompositions is probably the most tricky thing when it comes to optimizing compose performance, because recompositions can be super, super tricky. There can be tons of reasons why recomposition is happening that is everything but intuitive. So if that's really something you need to look at, then please only because you really need to, because you really have performance issues with your Compose UI. And you've already eliminated all those other factors that could have caused this issue, like as I said, accidentally calling expensive state updates in the view model on the main thread. So I hope this helped. As I said, this course will come up soon. You will also be able to buy this, but if you're a campus member, then you will get access to it for free. If the campus is something you are hearing about for the very first time, then I will include a link down below It's really not just about those challenges. It's about having a close community. Me and my team is active there. We answer your questions about Android development. There are regular Zoom calls where I answer your questions, where I review certain chosen members' code from these coding challenges, where you can get direct feedback from me on your code. So lots and lots of stuff that you really get in this campus community in order to really practice your coding skills and get ready for the industry. Link is below. Thanks so much for watching. I will see you back in the next video. Have an amazing rest of your week. Bye bye.